Salutations, mini mathematicians. So happy we can be here together today. So taking a look today, we're doing 6.0 C review, triangles and other shapes. So our purpose is to review our vocabulary for our geometry unit and to review some really important angle relationships and shapes, especially a very special one in triangles, any triangle, any size, any shape. And for that activity, you will end up needing scissors, some glue, or tape, and you'll definitely need your protractor today. So very exciting. Let's get started. So you have this packet for our lesson today. And this is going to be broken up into, I believe, 3 different activities for us to explore. So our first activity, part 1, has to do with reviewing that vocabulary you had in 6.0A packet and looking at some shapes. So for example, part 1 gives us this quadrilateral that's broken up into many shapes inside. And we're asked to name the following using this figure: a scalene obtuse triangle. Remember, scalene means all different sides are a different scale. So they're all different sizes. Obtuse means one angle is going to be greater than 90 degrees and less than 180. So looking here, if I wanted to find a scalene obtuse triangle, one I could look at is this triangle. And this triangle is triangle. We can call it LKC. We can call it CKL. I'm going to call it CKL. So maybe you see another triangle that is a scalene obtuse triangle. If I wanted to look at another scalene obtuse triangle, maybe you're looking at triangle LBC. So again, you only have to find one shape that matches the description, but yours might not match mine exactly, so just be sure to communicate with your group. So we're going to pause the video. You're going to be working on finding these shapes, and we'll get together as soon as you're ready. Okay, let's see how you did. So some possible shapes that you could have found. The next shape we're asked to find is an isosceles right triangle. So isosceles means one side is isolated, meaning there's one side that's different and there's at least 2 sides that are the same, congruent, if you will. So I found a number of different triangles. Remember, your triangle may be written in different order. Obviously, triangle OPQ is the same as triangle PQO. Okay, so taking a look, these are some possible triangles. I'd like to highlight triangle ABL for you. So ABL here is isosceles and right. You can see that right angle, and isosceles is at least 2 sides are the same. So you could have all 3, but at least 2. Nice. Let's look at the third one. The third one asks for an isosceles obtuse triangle. So again, isosceles, at least 2 sides are the same. Obtuse means at least one angle is greater than 90 and less than 180. So I found 2 triangles, and I'm going to highlight M and O for you. Very nice, very nice. The next one asks for a parallelogram. So a parallelogram is a type of quadrilateral. It has 4 sides where all opposite sides are parallel to each other. So a parallelogram you might be very familiar with is a rectangle or a square, but they can also look like parallelogram MOQK. So I'll add that to here. I guess I have that KMOQ. I just wrote it differently. So KMOQ, that is also a parallelogram. Perfect. Number 5, a rectangle that is not a square. So AEGJ, this entire shape, is a rectangle that is not a square, but notice OQHF there is actually a square. And the next one we looked at is a trapezoid. So a trapezoid is another type of quadrilateral. but it has one set of parallel sides and the other two sides are not parallel. Sometimes I say it's how you trap a tiger. So if we had a pit in the ground for the tiger to get trapped in. So one trapezoid I'd like to point out with you today is DEFO. So DEFO, notice DO is parallel with EF. So they're parallel to each other. But DE and OF are not parallel. So one pair of parallel sides. Very good. Next one says a rhombus that is not a square or a rectangle. So a rhombus is another type of quadrilateral. It's a four-sided figure whose angles are not right, and they have equal side lengths. So one such rhombus is rhombus SONM. So SONM. So this is a rhombus. Notice it has four sides that are congruent. They're the same length, but we do not have 90-degree angles. And the last one I asked for is a quadrilateral that is not a square, not a rectangle, and is not a trapezoid. So we're just looking for funky quadrilaterals here. So one such funky quadrilateral is MCON. Notice it's four-sided and it's closed, so it is a quadrilateral. However, it is definitely not a square or a trapezoid. Trapezoid. Rectangle trapezoid. Have you heard of it? A trapezoid? No such thing. But not a square, rectangle, or a trapezoid. And those are some other options for you. Nice work. Okay, let's look at the next part that I'm going to be asking you to do. So the next part is to determine if statements are true or false. And if they are false, correct a word or phrase to make the statement true. So let's do the first one together. It says, a line is a flat surface that extends without limit in all directions. So a line, I guess you can consider it flat, but it doesn't extend in all directions, it only extends in two directions. So if we look at that vocab, what's a flat surface that extends without limit in all directions? A plane. A plane. So we're going to write false here. And we're going to say a plane. Perfect. Let's do one more together. The next one says congruent triangles are triangles that have the same size and shape. And that is true. That is true. Congruent figures have the same size and shape. And I like to think about congruent figures kind of like being cookie cutters. If you only had one cookie cutter, everything's going to be the same size and shape. Perfect. So why don't you finish the rest of this page through 14, pause the video, and we'll go over our answers as soon as you're ready. Okay, let's see how you did. The next one, the sum of all the angles in a triangle is always 180. So that is a false statement because they said sometimes. So cross out sometimes and put always. We're going to be proving that today in our activity. The next one says an acute angle measures between 90 degrees and 180 degrees. Well, that's false because we know acute angles are between 0 degrees and 90 degrees. 13 says supplementary angles up to 180, and that is true. And on your vocab, we went over that. And if you look at the word supplementary, notice you can draw a line through that S and it makes an 8. So that's kind of a quick trick of knowing which one is 180 degrees. Right triangles can have more than one right angle. Well, this is false. They cannot have more than one right angle because remember that the sum of all the angles in any triangle is always 180. It's not more than 180. It's not less than 180. It's exactly 180 degrees. So if you had two angles that were 90 degrees, well, 90 degrees and 90 degrees is already 180 degrees. So a triangle has three angles. You can't have our third angle being 0 degrees. So that's why this is impossible. Perfect. Great job, mini mathematicians. Okay. So The next page talks about circling the answer that best describes the definition and then classifying the triangle by side and angle. So 15 says points that lie on the same line are called, and sometimes drawing a picture can be helpful. So maybe if we had A, B, C here, so these 3 points are called collinear. So they're like co-captains of the line, collinear. The next one says a part of a line that extends indefinitely in only one direction is called a, well, this is what it might look like. Indefinitely in one direction, that's definitely a ray. Really nice job there. And the last one says a collection of points that extend in two directions without end is called a, so extending in two directions, we can have multiple points there. That is called a line. Nice. So the next 4 problems, we are classifying the triangle by side and angle. It's not drawn to scale, so we're not pulling out our protractors to measure these. We're just taking a look. And remember, these marks are congruency marks. So this tells me all 3 sides are the same. And if all 3 sides are the same, that means the angles also have to be the same. So by side, all 3 sides are equal. That's an equilateral. So equilateral. And if we have all these angles adding up to be 180 and they're equal, well, 180 divided by 3 is 60 degrees for all these, which means it is acute, equilateral, acute triangle. Nice job. Okay, so taking a look at the next one, well, here I have 2 sides that are the same and a third that is different. And it's pretty obvious if I had a right angle here that this is greater than a right angle. This is greater than 90 degrees, making this an isosceles, obtuse triangle. Nice. Oops, forgot the word triangle. Go ahead, finish the last 2, and we'll go over our answers as soon as you're done. Thank you for pausing the video. Okay, let's see how you did. So this second to last one you had to do is a scalene right triangle. It's a scalene right triangle because we obviously have a right angle making it a right triangle, and it's scalene because we have all 3 different sides of a different size. They're all a different scale. And our last one is isosceles acute. Isosceles has at least 2 sides that are the same, and it's acute because we can totally tell that all 3 of these angles are less than 90 degrees. Perfect. Good job, mini mathematicians. Okay, let's get into some of the fun stuff. So now we're going to do another true-false segment. If it's false, explain your reasoning. So the first one says an equilateral triangle is always isosceles. What do you guys think? True or false? This is true. And you might be saying, but wait, an equilateral triangle has all 3 sides the same. But an isosceles has at least 2 sides equal. So in fact, an equilateral triangle is an isosceles triangle because 3 sides being equal meets the criteria of at least 2 sides being equal. Fabulous. Let's keep going. An isosceles triangle always has 2 congruent angles. Well, this is false. An isosceles triangle, because of this word always, it might have 2 congruent angles because from what we said above, an equilateral triangle is also an isosceles. So if it's an isosceles triangle, this could have 3 congruent angles. And the symbol for congruent is an equal sign with a little tilde on top. Angles. And if you're not familiar with that, definitely put that in your notes. It means the word congruent. So false could have 3 congruent angles. So go ahead, finish 24, 25, and 26. Pause the video, and we'll go over them as soon as you're ready. Okay, let's see how you did. 24. A scalene triangle can have two congruent angles. This is false. Scalenes means no equal sides, hence there can be no congruent angles. Because when we're looking at the sides of a triangle or the angles, the smaller the angle, the smaller the opposite side length. The larger the angle, the larger the opposite side length. So if you have equal angles, you're going to have equal side lengths. Okay, next one. The sum of the sides of a triangle is 180. Well, this is false. The sides of a triangle can add up the perimeter to make all sorts of numbers, but the angles are what has to be 180 degrees. Side lengths can vary. The last one says an isosceles triangle has at least two congruent sides. That's true. Perfect. So let's get a little creative with looking at some shapes. So these are some fun puzzles, 27 and 28. What we're trying to do is we are going to count how many of a certain shape we see. So how many equilateral triangles of all sizes are here in the 3 by 3 equilateral triangle shown below? So my hint is there's more than 10, and I told you that this whole big one is an equilateral triangle. So if I just counted the big ones and the 3 medium ones, so like here's one, here's a medium one, here's a medium one, and here's a medium one. So already I have 4. Already I have 4. And then maybe you can start counting the smaller ones. So what do you think? How many same size equilateral triangles can you find? And then over here, I want to know how many isosceles triangles of all sizes and shapes are in the regular pentagon below. And I'll let you know it's more than you see in number 27. And there's a lot of different ones we can look at. For example, we have this one, we have this one, we have this one. So there's a lot of them. Oh, we have this one over here. So just in this little 1, 2, 3 triangles, I can make 1, 2, 3, 4, 5. Oh, and then 6. I can just make 6 just here. So go ahead, pause the video, spend some time counting, and we'll check in to see how many you could find. Okay, let's see how we did. Well, I'm not going to take the time to point them all out, and you can always come back and try to see, or maybe challenge a friend or neighbor or family member to see if they can find them all. But there's 13 in number 27 and 35 in number 28. Okay, let's get on to our next activity. Our next activity is we are going to prove that the angles in any triangle add up to be 180 degrees. So we're going to examine angles within any triangle. So below we have 3 triangles that we're going to cut out. But before cutting out these triangles, we are going to use our protractor to measure our angles to the nearest degree. And we're also going to measure our side lengths. And then we're going to record our measurements in the next table and then tape or glue the angles together on the next page. So first things first, we're going to measure these angles and a little review of the protractors. So this is going to be triangle number 1 for me. Notice that this angle here, what do you think it is? You're right, it's 90 degrees. So we have to make sure to line up our vertex and make sure you line up the 0 line with your line, and notice it goes all the way up to the 90 degrees. If we continue up, so we know that this is 90 degrees. I'm going to measure the angle over here now, lining up my vertex. And you see how this line isn't lining up with the 0. So I need to make sure to swoop, really line it up perfectly. And it's in between the 20 and the 30, so that is 25 degrees. And the last one, maybe you already know what it is, but I'm going to measure it just for having that extra fun practice of measuring. And I notice that it is, got to line up my zeros here, and it's a little bit harder to line up the zeros when the line doesn't extend all the way. But when I do that, I notice I'm in between the 60 and the 70. Notice I'm using the inside numbers because I want to always start at 0. So this is 65 degrees. I'm also going to measure the side lengths. Notice since this is 90 degrees, it's opposite the longest side length. 25 degrees is opposite the shortest, and 65 degrees is the mediumest angle, so it's opposite the mediumest side length. So if I go ahead and measure for centimeters, we're going to measure to the nearest half centimeters. That looks about 4 centimeters. So I'm expecting this to be longer than 4. Measuring it looks like it's 9.5 centimeters. And this last one, I'm expecting it to be in between them because it's opposite the in between angle. Make sure you're using the 0. It looks like this is 8.5. And I'm writing this on the inside because remember we're going to be cutting these triangles up. So let's go ahead and finish measuring and labeling the next triangles. So we're going to have triangle 2 and triangle 3. So go ahead, pause the video, and finish labeling your triangles. Okay, they should look something like this. So what we're going to do now is we're going to be using these values to fill in the table on the next page before we count or cut them up. So here's our table on the next page. And you can look at my triangles to fill this in if that's easier for you. So triangle, well, I guess we should probably call these triangle 1, 2, and 3. I don't know why it says 29, 30, and 31. So the angle measures on triangle 1, I got to be 25 degrees, 65 degrees, and 90 degrees. And we can grab our calculator to add those up. And if you add those up, what do you get? You're right, you ended up with 180 degrees. So taking a look at our next triangle, you notice that all those angles are 60 degrees. It's in fact an equilateral acute triangle. And 60 degrees, 3 groups, that is 180. And if we look at our third triangle, this is an isosceles obtuse triangle, 40 degrees, and 100 degrees. Two sides are the same, and we have an angle greater than 90. This also adds up to be 180 degrees. So down below here, it says tape or glue the angles together below. So I'm going to have triangle 1, triangle 2, and triangle 3. And what we're going to do is we're going to cut out these 3 triangles. We're going to cut out these 3 triangles using some scissors so that we have 1, 2, and 3. So go ahead, pause the video and cut them out so that we have our 3 triangles. Okay, now that we have our 3 triangles, what we're going to do is we are going to cut off the angles of them. So I'm going to cut off this one, triangle 1. And now what I'm going to do is I want to try and make 180 degrees by adding together these. And you can see I left a lot of extra white when I was cutting mine out. So I probably want to go back and cut so I don't have any overlap and I can fit these angles in snug as a bug so that we can really prove to the world. Okay, so we have these 90 degrees, 65 degrees. Does this fit in here? Take a look, you guys. I made 180 degrees. We've discussed how a straight angle is 180 degrees. That's why on our protractor, right, 180 degrees, one straight line, it lines up with 0. So you can take a piece of tape or you can take some glue and we're just going to show that voila, amazing, we made a beautiful straight angle, proving, at least with this triangle, the angles add up to be 180 degrees, aka a straight angle. So you're going to do the same thing now with triangle 2. So again, triangle 2 is a little funny because we don't want to cut the angle. We want to leave it as 60 degrees. So maybe we kind of just do a little triple cut like that. And then remember, you're lining up the angles to make a straight angle. Okay, so go ahead and finish with triangle 2 and triangle 3 and see if you can make some type of conclusion. So go ahead and pause the video and finish your little project. Let's see how we did. So this is what your concluding beautiful cutting and pasting, old school cutting and pasting original should look like, where we make beautiful straight angles. So our conclusion is the 3 angles in any triangle, does not matter the shape or the size, will add to be 180 degrees, which is a straight angle. Yay! So we're going to use that knowledge throughout the rest of this module. It's a huge, huge conclusion that we're making here. So the last page is that we are going to be labeling each triangle with any missing side measures to the nearest tenth of a centimeter. And it's okay, I know your protractors don't have little tenths on here. They're really to the half. So as accurate as you can to a half of a centimeter is fine. So we're going to say to the nearest half of a centimeter, and any missing angle measures to the nearest degree. And just do your very best. And then we're going to find the sum of the angles. We're going to classify the triangle based on the sides and the angles. So if I take a look at this first one, to fill in the missing side lengths, I need to find the base and this side. So always line up with your 0, and it looks like this is a little bit more than 8.5. But if you just kind of move it over, it looks like it's exactly 8.5. So I'm going to call this about 8.5 centimeters. So this is an approximation symbol. And again, since we are just kind of approximating, it's not exact. We want to communicate that. And it looks like this next one is close to about 5.5 centimeters, which is great because notice if this is around 75 degrees, 8.5 is the largest side. So this is going to be the largest angle. This is the smallest side, so this is going to be our smallest angle. So if we line up our protractor here, and it looks like this is just a little bit under 40. And notice if this is 66 degrees and this is 75 degrees, what do we have here? Well, this has to be 39 degrees. So you're going to have to use a little bit of math and your protractor to find those missing angles. So we're going to classify the triangle based on the sides and the angles. So this is 3 different sides, so they're all different scales. So it's a scalene. All the angles are less than 90 degrees, greater than 0 degrees, so it's acute. And it's a triangle because it's a 3-sided closed figure. Angle. And we're going to show the sum of the angles, that 65 degrees plus 75 degrees plus 39 degrees is equal to 180 degrees, which we're so happy about because we just proved it on the last page. So go ahead, finish 33, 34, and 35, and we'll go over the answers as soon as you're ready. Okay, did you notice something really cool about these? And it's something we've been saying, and I want us to make a little note of it on our notes. Notice how the largest angle is always opposite the largest side, and the smallest angle is always opposite the shortest side. So all congruent angles mean all congruent, all equal sides. So if you have all the angles that are congruent, it means all the sides are congruent. So this is a really important observation that we're making based on this page. So taking a look at our next triangle, we noticed we had all equal angles and all equal side lengths. So equilateral acute triangle, 60 degrees plus 60 degrees plus 60 degrees is 180 degrees. The next triangle we are investigating, and again, I know your side lengths might be a little bit off or different than mine, but that's totally fine. Here we had 7 centimeters, about 9.5 centimeters, 120 degrees, and 20 degrees. So this is a scalene obtuse triangle. All sides are different sizes, meaning they're all different scale. Obtuse because one angle is greater than 90 degrees, less than 180. And our angles do add up to be 180 degrees. And the last one you had to do, this is indeed an isosceles right triangle. You just have to have one 90-degree angle to just be right. You just need one to be right. Isn't that great? And it's isosceles because all two of the sides, at least two of the sides are the same measure. They're congruent, at least two congruent sides. And the angles do add up to be 180 degrees. Perfect. Great job, mini mathematicians. Appreciate all your hard work. Do your best to be nice to everyone, and I'll see you next time.